Mitchell and Eric asked me to introduce Steve today. Like all academics, Steve's life began in 2004 when he graduated from the University of Washington with his PhD in computer science and engineering. He was so tired of the cheap liquor and easy access to guns down in Washington State that he decided to come up here and join us at UBC, where he's been teaching courses ranging from introductory to discrete mathematics to upper-level programming languages and HCI ever since. In addition to winning departmental teaching awards in 2005, 2006, 2007, and 2010, the university's Killam Teaching Prize in 2007, Steve has dozens of publications on teaching and learning in computer science and got to go to Chattanooga, Tennessee as PC chair of the 2009 SIGSE, which is ACM's flagship conference on computer science education. His interests include, in reverse alphabetical order, just to be a little bit different, the intersection of elections and computer science, interactive engagement lecture styles, his family, dogs, cycling, CS education research, and board games. And he often blends his interests, as demonstrated by the fact that his 6-year-old daughter, Naomi, already requests tail recursion instead of just regular iteration. Because every evening she wants Steve to tell her the story of his day, and that story must end with, "And then I started telling you the story of my day." Although he hasn't updated his webpage since the Bush administration, he did become a senior instructor in 2009. He took a sabbatical last year and he's teaching Computer Science 311 this fall. And then Steve wrote me an email containing his bio. So in addition to his many teaching duties, Steve has been working on a project that he'll tell us about today with funding from the Carl Wyman Science Education Initiative. And as director of the computer science branch of the Wyman Initiative, I was delighted to see that Steve's abstract for today's talk hit every single buzzword from that initiative. So his content inventory will be used to sustainably probe the longitudinal impact of pedagogical change. But let's be clear that buzzwords aside, Steve is doing something novel, challenging, and perhaps a little bit frightening. For many of us who have engaged in the Wyman Initiative, one of the first steps was to write a set of learning goals for our courses. And the idea was that these learning goals would allow us to construct easy assessments and to provide students with a fair warning of what they would be tested on. I don't know about the rest of you, but the advice I got when I was told to construct some learning goals was that I had to state them in an active voice. The student will do something. And I wasn't allowed to use the word understand anywhere in those learning goals. Well, Steve's research has demonstrated to me the wisdom of that latter bit, because it shows just how difficult it is to build an accurate assessment of the meaning of the word, of something that is stated in terms of understand. So without further ado, I'll let Steve fearlessly guide us into our own little heart of darkness. Just what do students understand from our Foundations of Computing sequence?
Wow, that was awesome. I wish I could remember what Washington State was like, but my life began in 2004 after I got my PhD. All right, well, thank you, Ian, and hello, everyone. And you all heard what I was talking about. I do want to emphasize what I'm going to be talking about is developing a concept inventory, and that participle, I guess, is there because I'm not done. I'm not even nearly done. So I'm going to show you a little bit of results that I have from the summer, but I can't tell you exactly what our students understand or don't understand yet. There will be some fun stuff in there, though. I also want to say I have up there Foundations of Computing course sequence, which may be a surprise to most of you that we have something called the Foundations of Computing course sequence. We don't, but it's the best name I've found for computer science 121, 221, and 320. That's our introductory discrete mathematics and hardware course, where I'm focusing on the discrete mathematics side, our data structures and algorithms course, and then our second algorithms course. And to a lesser extent, we've also been looking at computer science 420 and 421. So, here we go. Well, first of all, what's a concept inventory, or why make a concept inventory? And hereafter, just so I can have some acronyms, I'm going to say CI. It will save me time, and I will only ever say so many letters and words in my entire life, so I might as well maximize what I get out of it. I'm going to start, since that's set notation up at the top. As you all know, you took Computer Science 121, so you're aware that I can do that in either order, and it's still totally acceptable. So I'll start with why make a concept inventory. So let me begin with some work that a student did with me, and I say it that way because she did the work, and I got a little bit of the credit too. On Computer Science 121 Labs, and I don't actually want you to get a lot of details of this graph, but this graph is the kind of graph that I would love to be able to get about student learning. So here we were actually measuring how much students like a couple of different elements of the Computer Science 121 Labs. One of them was the hardware side, and one of them was the software simulation of the hardware. And that red line is the software simulation of the hardware. And you can see something surprising happen to the red line where it breaks and then jumps up into a higher level, and that's when we changed our software from one that the students disliked to one that they liked. And we can tell that that happened because we've got longitudinal data that tells us that it happened. And that may not seem like a whole lot, except when you think about what evidence you actually have that any pedagogical change you ever made had any impact whatsoever. And usually your answer is, it feels a lot better. The students' grades are higher now than they were before, and so on and so forth. So one of the things that we want from a concept inventory, whatever it is that we'll be able to get this kind of graph. We'll be able to say over term after term after term what's been happening with students in terms of how they're learning our material in the foundations of computing sequence. The other thing we'd like to do is kind of surprise ourselves and change the way that we teach. We'd like to discover things about what our students know and don't know that might make us better teachers. So here is someone who's now a fairly well-known teacher, Eric Mazur, and in 1996 he published this article shortly after giving the force concept inventory in his class. That was the first concept inventory developed. And his students just did absolutely terribly on the force concept inventory. He actually tells a great story about how a student at one point came up while he was giving the force concept inventory to ask him a question. And this is the moment when he suspected things were going to go poorly. And the student came up to him and said, I don't quite understand what I'm supposed to do on these questions. And he said, what do you mean? Pretty simple questions. You just answer the question. We'll see one of the questions in a minute. And the student said, well, am I supposed to answer these the way I think they work or the way you taught us? And he thought, oh. That's bad. So this changed his opinion about what students know. He says, I now wonder how I could be fooled into thinking I did a credible job teaching introductory physics. And then he became Eric Mazur. This is when his life started. It wasn't after his PhD, it was here. And Eric Mazur is famous now for promoting interactive engagement in physics education. He's probably the foremost light in physics education on interactive engagement prior to our own Carl Wyman. Anyway, so that's a big deal, and that's something that this concept inventory accomplished. And while it was busy accomplishing that, it was busy being used in a bunch of other places as well. So this is from an article by Hake just a couple of years later, and this is with about 6,000. The article title says like a 6,600 student study or something like that. So 6,000-ish students taking this concept inventory and trying to gauge how well they're learning. And in particular, they took it at the start of the class and at the end of the class, and this is showing their learning data. It's a super complex graph. So I wouldn't worry too much about exactly what's happening, but the upshot of it was that they could use this all over the place, gather a bunch of data, and make conclusions about what was happening across a bunch of different kinds of institutions, across a few different kinds of pedagogical styles, and those conclusions were really meaningful and changed the way people taught. So here's my warning. Very grandiose goals beneath, okay? So pile up these things and you get something that's at least another PhD, and God knows I don't want to get another PhD. So I'm actually setting my sights on an instrument, a concept inventory, that will get value from right here. But this is my motivation. This is what I'd like to have. I'd like to have something sustainable, buzzword, buzzword, something that we can use over time to really understand how our students' learning is progressing through our courses, or regressing, maybe. And I'd like it to be usable in such a way that we could use it many, many times and gather that data together and maybe say things like what that Hake study said. Okay. So then what are these things? Well, here's where you get to pull out those clickers. We are, what are we? We're AA, so you shouldn't have to change it. I think they probably default to AA, which is good because I don't know how you change it because I always teach in AA, so I never have to tell anyone how to change it. So just turn on your clicker there, and we've got a question. I'll go ahead and start the clicker in case you're one of those people that wants to click in really early here. This is a concept inventory question from the Force Concept Inventory. I'm trying to figure out how to move it over to, it's a new, oh my goodness, this is bad. It's just gone off the edge of the screen. It's new clicker software, and I've never used it before. Please come back, clicker software. Anyway, let's not worry about that. So this is one of the questions for the concept inventory. You can see this is old because you can actually see the ink blobs that were scanned in. Heavy ball attached to a string, swung in a circular path on a horizontal plane. The string breaks at the ball, and we want to know, we're looking from above, which of these paths does it follow? So go ahead and click in. I'm not seeing anyone clicking in. Are we having a technological error here? I assume at least one person has tried to click in.
I clicked in.
Yeah, I did twice.
Oh, okay. Actually, I think I'm seeing it on the clicker software. I'm just not seeing it on this thing here. And I don't know if I can stop it because it went off the screen. I hate to do this to everyone, but I'm going to have to kill the clicker software and restart it. That was the 3-finger salute. And here's my task manager, and I'm killing the clicker. That's what I get for going on sabbatical. I haven't used clickers in a year, and the software doesn't work now. I'm blaming this on the software, of course.
I thought you were playing the software on your legal way.
That would be nice. Can the software make me go on sabbatical again?
Yeah, and it will stop working. I'll wait till somebody stops working.
You can't blame that on me. Okay, we're almost back. And what I'll do is I will not try to put it. Okay. And we are back. You should be able to click in again, and I can see you clicking. And now I can even move it over here. Okay. You've had plenty of time now, so 5 more seconds. Plus the time it takes me to walk over and hit stop. Okay. So that's from the Force Concept Inventory. Obviously, it's the kind of question you can read and answer, not necessarily correctly, but you can read and answer it without too much trouble. It's usable, actually, before you even take a physics course, which is nice. That's not going to be true of now I'm blanking out on whether I've put in any of the questions that we can use before 121, but it's not going to be true of all the questions that I'm developing. It will be true of some of them. But it does get at a pretty important fundamental concept. And it turns out that people get it wrong a lot. Let's just see how you did, if it's going to let me. Yeah, it is. Oh, you must be smart because you all agreed on the same answer, which means it's probably the right answer, right? Well, not all of you, 84%. Yeah, that probably makes it the right answer. And yeah, sure enough, that's the right answer. It follows that B trajectory. Once we've got no other forces acting on it in this plane, it'll just carry on in the direction that it was going. Fantastic. Okay, so that's a concept inventory, a bunch of questions like this. So what I'd really like, again, is one of these sustainable assessments. It's going to be a bunch of multiple choice questions. And I am constraining myself to multiple choice questions. I don't want any fancy analysis at this point. I want something really, really simple where we can do it quickly, we can get the data from it, and we can make some conclusions about what people learn or what they don't. The Force Concept Inventory has 29 questions and takes 23.3 minutes on average. Something that short, we probably can afford time at the end of each of 121, 221, 320, maybe in tutorial, maybe for a bonus point, something like that to ask. It's founded on previous and ongoing research. Basically, it's something you can give over and over again. That's what we're looking for. So, And kind of agrees with the research on what we should do. This is from a paper in IDISI, one of the main computer science education conferences, on how you should do this for discrete mathematics, and it basically says that sort of thing. So here's the thing. Shouldn't I just go out and write some questions then and give those questions out? And that's kind of, honestly, that's kind of what I thought they did with the force concept inventory the first time I saw it. They just wrote some questions. And maybe that's what they did, but here's what happens when I write some questions. Okay, all right, I'm picking on myself by picking one that's especially bad. But one of the things I've been doing is examining, you won't be able to answer this one because you're missing context, so don't even try. Okay, but I've been looking at previous exam questions, and I've analyzed over 200 of them. This particular question I wrote, and I asked of 121 students, and it wasn't even meant to be a hard question. It was actually meant to be an easy question. Here's what happened. The shading indicates how many people picked which answer. 49% of people chose the correct answer, C there, which actually made it one of the hardest questions, top 20% of questions by difficulty. Particularly hard for a multiple choice question. Multiple choice questions don't usually get that high into the level of difficulty because, people guess and sometimes they get the answer right. Bottom 5% of questions by correlation with students' overall grade on that exam score. Now that's not that unusual for a multiple choice question because multiple choice questions are usually all or nothing and correlation is hard to get when you're just all or nothing. But it did stand out a little bit from multiple choice questions. And here's what really made it stand out. Essentially uncorrelated with its own exams, other questions about DFAs. People who knew what they were doing with DFAs got this question terribly wrong. So, what was wrong about it? I mean, you could probably tell what's wrong about it just by reading about it. How could I be so dumb as to ask a question where I had to put phrases in italics just to draw students' attention to them so they wouldn't answer the wrong thing having the right idea in their head, right? But it turned out not to be just that I was adding how many more arcs are there from the existing states, and don't get confused by that. I did think-aloud interviews with the students where I had them write this question and many others that showed up as difficult on the exams or stood out in some other way. Where they basically work the problems and they talk as they're doing it. And before I changed the question at all, when I just gave it in this form, except with the context so they could answer it, here's the kind of thing that I heard. Okay, so arcs, I guess, would be arcs? What are arcs? Why did I have to say arcs here? Why didn't I just say arrows? It wasn't my job to teach them that arc means kind of the same thing as arrow. From the existing states, I can't find any more states. This person thought from the existing states to non-existing states? What do you mean? What does this question even mean? And even when they kind of understood the question, they were distracted by designing the correct DFA. This question was supposed to be an easy one where I just said, based on the basic requirements of a DFA, how many more arrows do you need? Don't even worry about what it's doing. There's just some arrows missing or it's not even a legal DFA. And instead, they were spending minutes trying to design the correct DFA and back their answer out from that. So I rephrased the question a few times over a few iterations, and eventually students understood what the heck I was talking about, except they were still distracted by trying to get the correct DFA. I was just unable, with any amount of words, large or small, thrown at the students to keep them from doing that. So basically, communication is hard. I mean, you all know that. You miscommunicate all the time, right? I miscommunicate all the time. And we've got so little bandwidth to talk to students on exams. But we want to communicate very, very clearly with these concept inventory questions. So one of the things we want to do is design these, try them out with students in this think-aloud format, go through that many, many times. So we have some confidence that what we want them to understand is what they're really understanding. There's another problem, though, which is that multiple choice questions are games, and students know how to play these games. So I'm not going to show you a bunch of data on this one. I'm just going to have one student quote that was tons of fun from the think-aloud. This student, I should say before I put that up, this student said, out of the student's own mouth, exactly what we wanted from the interpretation of one of the distractors on this question, this thing that students had been saying that we wanted to probe. So this was a perfect student. The student had the misconception we wanted. We had an answer that precisely fit that misconception. The student saw that answer and said, that looks like a good answer. And then the student said, I guess I don't like A anymore because it's a little ambiguous. That seems like a nice way of saying, the phrase from the other response. But usually a nice way usually involves being more explicit. So I'm going to go with B, despite it having the longest answer and it seeming a bit too obvious and too long. So this student is making sure that how long is it? How does the phrasing compare to other answers? Is it explicit or ambiguous? This is a student very good at playing the game. I can't remember if B was the right answer or not. It kind of doesn't matter. For this student, the right answer was A. Why didn't they choose A? Okay, so that's the other problem we're facing. So we want to design questions that will work in the face of this hostile environment. Okay. So now we kind of know what a concept inventory is. It's basically a very carefully designed multiple choice exam, except it's not an exam that's going to be graded, that we can give quickly, we can give it sustainably, and we can see how students are doing over the course of their career. And by the way, I showed you this horrible question that I gave. I do want to say, even if you have horrible questions, it doesn't mean that you're not doing a reasonable job of assessing your students. If you took all the multiple choice questions on this exam, and you considered them collectively, there was one big bunch of them, and then there were a bunch of non-multiple choice questions later on. It was the 4th highest correlated question as a whole of all of the 200 plus questions that we looked at. Okay, so yes, several of the multiple choice questions were bad, but as you might expect, law of big numbers, in aggregate, it correlated reasonably well with how students did on their exam. So I'm not trying to say that you're all doing terrible things on your exam. I clearly am, but you're not. Okay. So next up, I'm going to start in on the exploitation of you. So you've got clickers. Why do you have clickers? I mean, typically I'd hand that out so that you would learn more, but actually I'm handing it out so that I will learn more. So one of the things I need is expert feedback on these questions, and I was going to be giving this talk anyway, so I thought I'd get your expert feedback. So I'm going to ask you one demographic question. It's going to be what your role in computing is. Please feel free not to answer it, and not to answer any subsequent questions. I have no way of identifying you from your clickers, except Rachel, who brought her own clicker, and I live with her so I can get the number off of it. Okay.
Are you going to correlate this response to other responses later, though?
Yes, it is my plan to correlate this response to other responses later. Not right now, but later on. So here is the question, and let's see if I can find my little clicker thing and start. And I'll just give you 10 seconds to answer. Oh, by the way, if you're not a student or a postdoc or faculty, you might be wondering why you had to go into this other spot. I can only tell you that I worked hard to not put in the word actually before working. So you're the actually working folks. All right, so let's can that one. And I don't think we need to go over those results. Those are just for my exploitative purposes. So carrying on. So how do you make a concept inventory? And I'm kind of hoping maybe that's some of what you're interested in. And I'm going to try and highlight which parts of making this are the most valuable, because it's super duper labor intensive. And you probably don't want to go through all of what I've gone through in order to get partway through making a concept inventory. But you might want to do some of it. So here's kind of the idealized methodology. Gather goals by interviewing faculty, augment and winnow those goals, draft questions to assess the key goals, validate expert responses to the questions, collect student misconceptions through these think-aloud interviews, and then formulate forced answer, multiple choice versions based on those student responses. That's really important if you're going to make good questions. You really, really want the students' responses to be the source of those questions, because you will often be surprised at how they respond. And then you validate those questions in more think-aloud interviews, you pilot it, you use it in courses in general, and so on and so forth. And this does fit pretty well with the literature. So here's the Almstrom paper that I mentioned earlier, what they say you should do, and it's somewhat similar. And here's Adams and Wyman, Carl Wyman and Wendy Adams from both the Colorado and the UBC science education initiatives, and it all kind of fits with what we did. Practically, what have I been doing? I've been doing instructor interviews to figure out important topics. Will?
What's a forced answer?
Forced answer in this case is just meant to say that you don't get to write anything you want. It's not like in a, you may have heard in a Likert scale where you say, you know, strongly agree to strongly disagree. If you leave the middle out, it's forced in the sense that you can't say neutral. I'm just talking about there are a set of responses and you have to pick one of them. You can't make up a response of your own. And by the way, please interrupt me with questions. Does anybody have any questions? Because otherwise I'm probably going to talk right over your question period. So. Okay, here's what I actually did. I did instructor interviews to try and find out what were important topics. I did a bunch of exam statistics, which I already discussed really briefly. We also looked at, and I shouldn't say I, this is very much a we. I've been working with a lot of different people. We also looked at a bunch of different course artifacts. So that's project reports from projects that students have turned in, scans of their exam results, so on and so forth. Did think-aloud interviews. Each of those was about an hour long, and so far I've done 29 with students, where we give them problems, and then we shut up, and we watch them work the problems after having trained them a little bit to speak aloud what they're thinking. That's kind of the super short summary of what a think-aloud interview is. And then I've piloted the concept inventory a couple of times. Crucially, this is, as you might expect as computer scientists, not a waterfall process, all right? It kind of sounds like it when you read the other papers, but it's a lot of tightly interlinked cycles. So insights that you get from one place here very much feed into what you do in the other places. And you get a lot of value out of revisiting each of these elements. And I did promise I'd say what I found really most valuable here. So let me say right now that if you're thinking about doing this, I think about the most valuable pieces that you could do cheaply. Well, instructor interviews you can do cheaply. Just talk to your colleagues. That's really good. But I'm guessing you already do that. These are very expensive to do, but they're not that expensive to do just a little bit. Take some exam question after you're finished with the marking. Use Anthony Winstanley's amazing exam scanning system. It's great. I can send you a script that'll rip apart your PDF of your exam and then give you just all the questions in a row. And go through those questions and just bin them into categories. How did students respond? And then count up those categories. And you'll often discover really, really interesting things. And that's basically what we did with the course artifact analysis. And then with the think-aloud interviews, find some time after your course is over where you can contact 3 students, one A student, one B, and one C that you know would be willing to chat with you, and just have them sit down and work those final exam questions again right in front of you, thinking aloud, if they're willing. And you learn a lot about how students approach the questions just by watching this a very small number of times. So those are the ones I'm gonna sell to you. Doing a whole bunch of exam statistics, probably not as valuable, although there are a few that you could do for your own exams that might be. So, any questions up to this point? So we know what a concept inventory is, we know how we're going to do it. Here's how the rest of the talk goes. I'm just going to tell you the story of 3 concept inventory questions. And I'm not going to tell you what questions they are before I start. Why is that? Because there's about to be another clicker question. So let's just do the clicker question. Oh, great. This is covering up the very top, isn't it, here? Let's move it way down here. Someone who's a student, does the light change color or something?
Turns green.
It turns green.
It turns green. If it's registered, it turns green. All right, awesome.
Well, you can just keep pressing.
Now you know.
Or if you want to vote twice.
All right, 3, 2, 1, 0. There we go. Oh, don't start again. There. Okay, good. All right, so, I'm just going to look at those results. Oh, it starts up where it was before. Oh, blast. Okay. Well, this is kind of good. So it's kind of good in the sense that this is not how students answered, but it's also kind of good in the sense that it is reminiscent of how students answered. So let's just keep going. I meant to come back to those. I meant for that to appear on my screen, but this version of iClicker works differently. Thank goodness I'm doing this before I'm using clickers in class.
If you pull it over to your slide now, when it reappears, it'll show back where it was.
Yeah, I figured that out, but thank you for confirming. Okay, so where did this question come from? It actually started with a paper at SIGSE 2012 on concept inventory questions for data structures, basically, by Danielsick et al. And this is one of the questions that they asked, but it was a nice, simple question you could definitely imagine reusing. It's basically a multiple choice question. We've got 4 tiny little trees, and we want to know for each of these, is it only a heap? Is it only a binary search tree? Is it both, or is it neither? And here's kind of the neat thing that they noticed. Actually, let me get rid of the detailed quote and just focus on this. The neat thing they noticed is that students tend to conflate heaps with binary search trees. They found students saying, where something was a binary search tree, it was also a heap, and where it was a heap, it was also a binary search tree. And that was kind of surprising to me. I mean, I've taught heaps and binary search trees a lot, but it had never occurred to me that my students are confusing those two. Like, what, just because they're both binary trees or something like that? And we are specifically talking about binary heaps here. Weird. So we gave this question on a Computer Science 221 exam, and the results were very interesting. This was actually by far the most interesting tree. Most students say this is a binary heap. It's not a binary heap because 6, that bottom node there, ought to be on the left. It does not have the binary heap shape. Super easy to overlook, but certainly interesting that people did, even in this very, very small tree on a final exam in Computer Science 221. 18% of students incorrectly say this is a binary search tree. That's probably because of something that's also been mentioned in the literature. Alan Fekete mentioned that students have this habit of checking parents and children for the search tree property. So the left child of a parent should be less than, from your perspective, the left child should be less than this node. The left child's key should be less than this node's key. The right child should be greater, but not grandchildren, great-grandchildren. All descendants on the left side should be less, and all descendants on the right should be greater. But that 6 is in the wrong subtree of 3. So those are both kind of cool, and we'll use this question. It's a very simple to ask question, and it gets at something kind of neat, and somebody else has already done the work of doing think-alouds on it, which is fabulous. But almost no one confused heaps and BSTs as described by Danielsick et al. They described a specific pattern we should see, and we did not see that pattern. So, we figured, nothing going on. Yep?
4 is larger than 3, so I only need to look at the root.
Oh, I'm sorry, I must have pulled the wrong tree for this. Very good point. Will says you only need to look at the children on these. There was another tree that I guess had a 2 under there or something. I will just remember to fix that in the talk for next time. Thank you, Will. Okay, so we figured no need to look any further for this heap BST thing. It's not going on with our students. We didn't ask it in the think-aloud interviews. But of course, we did ask a lot about binary trees and binary search trees, because that came up as important, fairly obviously from the instructor interviews. And it also shows up on a lot of exam questions. And here's one of the questions we asked. We asked a number, I think 5 different questions that were about binary search trees one way or another. 11 students who had studied both binary search trees and heaps answered these questions. And here's some examples of some really surprising and interesting things we got. This first one is maybe a little hard to see exactly what's happening, but there is a very heap-like shape embedded in there. If I had video of it, it would be clearer. But fortunately, another student wrote it in a much clearer way. This student ran into this problem and said, "Oh, I'm not quite sure how to proceed," sat back and thought for a while, and then said, "Oh, I know what shape this is. It's gotta be A, B, C, D, E, F, G, H, I, and now I can just put the A's and the B's and the C's and the D's in the right place, and it'll all work out." Okay? It's got to be this shape. So it turns out of those 11 students, 5 of them answered these questions in a way that made us think maybe Danielsick et al. Were right, that they were conflating heaps and BSTs somehow. So we thought, oh, we really ought to do something with this. And when we started examining the exam evidence, I hate it when I say that. When we started analyzing the exams, we saw a bunch of similar things. So this is one of my favorites. This was a student answering a question where we insert 10,000, 9,999, 9,998, and so on in decreasing order into a binary search tree, and the student tells us how long that's going to take. What's the asymptotic performance going to be? And the student says, well, because it only checks the tree for half of n at every split, it's log n complexity. This is a nice textbook diagram of how binary search trees work and why, except of course that this binary search tree does not look anything like this. It's a binary search tree with 10,000, 9,998, all the way down. It looks like a linked list. Right, so it doesn't behave this way at all. And we saw a bunch of other evidence that whether or not they're conflating heaps and BSTs, it kind of looks like they feel like binary search trees, they just gravitate to a state of balancedness. And in some sense, that's what we tell them. Alan?
So this answer looks sort of too suspiciously like what profs would often say in class, or like, did you have a sense, did the student actually believe this answer, or was it just kind of like a parroting of?
Yeah, so Alan asked, does the student actually believe this, or is this just parroting what they might have had in their notes? Because this particular exam was an open note exam as well. And it's hard to say. It is very common in the exam analysis to see what we call textbook answers, where the student does a very nice job of giving back some textbook description of the algorithm or the data structure or the concept that's got nothing whatsoever to do with the context of the question. So does the student really believe this or not? We don't really know, and we can't tell from this because this is exam analysis. In think-alouds, we can actually tell a lot better. So we decided to go ahead and try asking these questions. We made a few of them. Several of them, when we threw them to the wall, did not stick. This one stuck, and this is how students answer it. I guess I should bring up how you answered it as well, right? Maybe not, because that's too big. And for some reason, my computer is going so slowly that I can't move it. Let's resize this down. Please? Please resize? If I ask really nicely, it's not. Okay, well, you mostly answered E, and then you answered B a little bit, and the rest of the answers didn't get a whole lot of traction. And now there's a big red strike across here. So the students mostly answered E, although mostly here is not majority, it's plurality. 42% answered E, that's great. I want to skip this second highest one to go to this 21% one. I'm just going to flip forward to the next slide, and you can watch the amazing high quality animation as you see that, come on, flip forward to the next slide. That I changed the question. So this is the question that you saw, and this is the question that the students saw when we gave this at the end of a term of Computer Science 221. We realized that C is a really natural answer. If you just read the question very quickly and try to answer it as fast as humanly possible, which is maybe what you're doing, right? Keys, 1, 2, 3, 4, 5, 6, 7, binary search tree, there it is. So we wanted to try and keep students from doing that. We already know throwing words at students does not necessarily help, but we thought it might help a little bit. So we're going to try and avoid that a little bit. It's hard to know how much of that 21% is answering because they misread the question and how much is answering because that's what they believe it would actually look like. We don't have think-aloud evidence yet to say one way or the other. But these 27% who answered B, and actually in some sense the 9% who were even more confused with heaps and BSTs who answered D, so what is that, 36% overall, about a third? That's very interesting. They seem to think this should be balanced-ish. And that seems to be pretty robust. We get that a lot with students. We've done some think-alouds on this multiple choice question, and we get reasoning from the students that sounds kind of like what we expect them to believe according to this misconception we think that they have. I just want to pick B because it looks the nicest. And it does look the nicest, right? It's the nicest tree. And the next student really says that. I'm going to assume they're looking for the perfect BST that contains said keys. And that is the perfect BST that contains these keys, right? So students feel there's a rightness to these balanced trees. And that seems to be affecting the way that they understand how the trees work. So that's the kind of thing we want to find. This is a relatively mature question. We've seen evidence from the literature. We've seen evidence from our think-alouds. We've seen evidence from our exam analysis. We've gotten it out to students in multiple choice form. We've done some think-alouds on the multiple choice. That's kind of the story of how you develop a concept inventory. And that's the end of this concept inventory question story. Does anybody have questions about this one? Okay.
It seems like a tremendous amount of work to find out one kind of misconception about trees. What are you going to do with that information that justifies the amount of work that you've done?
Hopefully, so the question was, it seems like a tremendous amount of work to find out one misconception that, maybe wasn't that non-obvious beforehand too, although you didn't say that part. What are we going to do with it? The answer is we're going to use it over and over again. So I hope it's an investment that pays off in being used for a long time, because it's something that matters and something that is hopefully a fairly resilient misconception in the sense that we're going to have to work a little bit to overcome it. So if we think it's worthwhile to overcome, and if it's a resilient misconception, and if we really can reuse this question over time, then we've accomplished something. Now, this isn't the only thing that came out of the work. We've got some other questions. We've got some related misconceptions. This is definitely the one that's cleanest, where I can throw it up here and I can tell you with some confidence, people are answering this for the reason that I believe they're answering it, and it is a misconception, and it is a problematic misconception. Yep.
When this question was done during the think-alouds, was there sort of a delineation between those that picked B and those that picked C, where they recognized that both were trees, but one was more tree-ish? And the same way that 400 might be more even than, say, 798?
We tried to do some cluster analysis on the people who picked B versus C, the people who picked B versus D, and on some other questions that were targeting similar misconceptions. And what I can tell you is we don't have enough data yet. This is about, Kuba, this is 70 or 80 students, something like that? Yeah. Ask me again when we have 800. And I think we'll be able to say more. Yep.
So it's not completely clear to me that this question is testing understanding of binary search trees or sort of logic. I mean, it's saying here's a construct, namely a binary search tree that contains certain keys, and here are 4 examples of actually valid such trees. So you could ask an arbitrary question, here's a concept, here are 4 valid examples, might have nothing to do with the trees, and then it would be interesting to see how many just choose random ones. So if they do, it's because their interpretation of the question is, that's a binary search tree that contains the keys. So it's the logic as opposed to like the example you gave with the knight, it's a nice looking tree. That shows complete misunderstanding. It doesn't show at all a preference for balanced or whatever.
Oh, well, I shouldn't say exactly what else those students said, but they said a lot more than that, right? They didn't just say this is a perfect tree or, this is a nice looking tree. I'm not going to try and quote those students because that would be bad when I don't have the quotes in my head. But they definitely did reason about the trees that were available and say, how am I supposed to pick this? Oh, well, I'm having trouble. They'd like eliminate one and say, this one's really nice looking. This one feels good to me. So I don't know to what extent I can answer that critique, except to me, I feel like the think-aloud evidence supports the idea that students are picking this for a reason. They're not just picking randomly. And that reason has something to do with a pattern that we've seen at larger scale with more students in our exam analysis and in our previous think-aloud data. Will?
I'm going to ask this question again.
Okay.
Because I'm curious to know if, so there are multiple correct solutions in this question if I didn't have part E. So if I cut it up E, there are multiple correct solutions. Mm-hmm. So what if you ask this question without E?
Ask them a question without a correct answer.
No, there are multiple correct answers.
There is not enough information to tell. So at that point, there isn't. So what shape is a binary search tree? I mean, it's not exactly shape A. It's not exactly shape B. We don't know which shape it is.
But it's suppose I didn't read exactly.
Okay.
No, I'm just trying to get at Ian's question, which seemed to be like, if there was multiple correct solutions.
Then any solution is equally valid? Is that the idea?
And they picked the most beautiful one.
Oh, okay. I mean, the think-aloud data suggests pretty strongly that they're not thinking that there are multiple correct answers. They're thinking that they're not entirely sure how to pick the right answer. And so they come up with a metric that they think is appropriate and important. Is that fair as a response? I'd be pretty uncomfortable asking them a question that I did not believe had a correct answer, because I think that that could have a real impact on the rest of the questions. Yep.
So it seems like there's another misconception that's implicit in the formulation of the question.
Oh, good. What's that?
Well, that binary search trees aren't necessarily formed by insertion of keys. They might have arrived in some other fashion. So it seems to me it would have been more useful in this question to have said a binary search tree is formed by insertion of the keys in some order.
Okay. So first of all, I'll say that the version that the students saw did not say anything about insertion. It said contains keys. So this draft text in bold here, the students haven't seen yet. I totally agree. I'm just trying to think of a short way that students will actually read to protect against my concern, which isn't validated in think-alouds, that they might be picking C for the wrong reason, if that makes sense. A wrong reason that we don't want them to pick C for. But you were about to suggest wording, so suggest it.
No, I mean, I think that there not being enough information to tell is somehow a little bit ambiguous because a student might scratch their head and say, well, if I really studied binary search trees better, maybe I would have known that there was something attached to that would tell me the answer. And what you're really trying to ask here is, since I don't know the insertion order, I can't choose.
Yep.
Right? And somehow it seems to me critical that the uncertainty here relates to the order of insertion of the keys.
Well, anyway, the method of formation of the tree. I agree. I mean, we can argue about whether you think this is an appropriate or important thing to assess. In terms of, should an expert in CS be able to answer it or not? I don't have the data for you completely yet, but I can say that this group did do a lot better than the students did. So, yep.
The tree that is exactly shaped. So the tree that is exactly shaped B is a binary search tree that contains these keys.
Yeah.
So there is sort of an English language sort of thing that relies on sort of an English interpretation that says exactly this shape is a binary search tree.
I agree.
Asking whether
So let me mention another piece of advice that you get when you're designing a concept inventory, which is that experts have a very different view from non-experts, and you want to write a question that will be acceptable to both of them. So this was my chance to show a lot of people in the department who haven't seen this before the work, and I kind of expected that the experts would have a lot of critiques for the questions. That said, I don't see much evidence that the students are misreading it in the way that you describe. I think that is a natural way for an expert to pick at it, to really say, well, what is this actually saying, right? We're really good at logic. We're really good at constraints and what's happening in this problem. And I would like to rephrase it to satisfy that concern, but I'd like to do it in such a way that the students still understand it as well. Yep.
To drone on. I think what you mean by the word exactly is always.
Mm.
And those are not the same. I think what you're trying to say is that it always isn't that shape. But that's not the same as what exactly means.
Yeah, that sounds like a potentially good reword. Okay. So here we go, on to another concept inventory question. All right, and as the one there suggests, this is actually several concept inventory questions. Give it a shot.
Prof's not used to the clicker, at least my clicker keeps turning itself off. So if the blue light's not on, you have to turn it on first.
This means ask clicker questions more frequently in your classes than I'm doing right now. All right, let's take 5 more seconds on this. 4, 3, 2, 1, 0. All right. So that's the first one. Here's the next one. Same text at the top, just a different description of the function. All right, 5, 4, 3, 2, 1, 0. And I'm hoping you'll also gain some benefit from doing these as you think about, gee, what would students say to these questions? So I will torch you with the remaining 2 versions of this. And 5, 4, 3, 2, 1, 0. And last one, I promise. Oh, that was quick. All right, 5 more seconds. 4, 3, 2, 1, 0. All right. So obviously this is about exponentials. So where did this come from? Actually, not too many instructors saw this as a concept that was both important and also difficult for students, which was roughly the prompt that I was asking of instructors. It is in the 221 course learning goals. Folks in mathematics who are doing research in concept inventories also mentioned this when I started talking to them about it as something, oh yeah, we've got this concept inventory in mathematics that assesses it. I took a look, and it's not clear how much of that we can adopt. It's kind of not what I expected, but I'll see what I can adopt. We actually did assess it later on. We actually did try to build concept inventory questions later on because of some analysis of think-aloud data and 221 project reports. We actually started with the think-aloud data, but the very best quotes come from the project reports, so I'm just going to go straight to those. These are students doing a big project in Computer Science 221. This is a tiny selection of the available quotes. I certainly wouldn't say the majority of students said something like this, but a large minority. How do I draw log n again? For n increases very slowly as the number of operations increase. The key idea, I think, is that it's not exponential. It shouldn't blow up. Log n's not exponential. It doesn't blow up. Okay. I can't tell if doubling each time is a squared or a power of. Because it doesn't balance automatically, the insertion time increases exponentially as more items are added. We're talking about a not self-balancing binary search tree. Quadratic probing's performance will not degrade as quickly since it jumps exponentially farther with each unsuccessful insert. Yeah, there's a lot like this. So So we decided to have end of term 221 students in another section just build our concept inventory for us. We were giving them the concept inventory on which you saw the results from that previous question, and we put one open-ended question on that right at the end. And students were very nice to us. They mostly answered the question, and they mostly put a fair bit of effort into answering it too. Only, I think, 14 of 78 exam papers were left blank, which is amazing for something that was worth nothing. And here's kind of the range of correct-ish answers, if you like. So these are correct, or they're at least on track. And they were actually all over the place. 2 to the k, recursively calls itself multiple times per run, so on and so forth. My favorite is actually the bottom one. The easiest way to answer that would be that the function would execute a set of nested for loops proportional to the size of the input. It's like, that's the easiest way, wow. So if the input is 4, it's going to be a quadruply nested for loop, and if the input is 5, it's going to be a quintuply nested for loop. I'm like, wow. That is, super exponential, if you like. So it's, it's on track, certainly. There were a lot of people who answered that sort of thing, but there were a lot of off-track answers. There were actually 15 that were very similar to these. This was something that there wasn't a lot of variation within the answers. At least a loop within a loop, exponential. A loop within a loop with both loops running a number of iterations dependent on some variable, exponential. Nested for loop, exponential. I would show you a range of different answers, but there wasn't actually a whole lot of range in these answers. They were really saying this, basically. Alan?
Was this recently enough? These are mainly 111 products?
Let's see.
110 or 111 products? I find the 110 students are much stronger on recursion than they used to be and much weaker on loops than they used to be.
So first of all, I have some evidence that this, which I don't have in the talk, so I'd have to look up the numbers for you, that the students have misconceptions about what results in exponential blow up across both recursion and iteration. Not a ton, but I have some that suggest it's both. I suspect this was about half and half 110, 111 students, but I couldn't tell you for sure. I'm basing that on my 311 students this term and what I know 311 was last year.
A lot of students have issues with exponential functions, even from the purely mathematical point of view. Mm-hmm. They forgot all they learned about exponentials in high school.
Or maybe they learned something different from what we think they did. So here's another relatively common answer. The one at the bottom was hard to get readable on the slide, so that's why it appears to be in a different color. It must be order n squared. It must have a time-space complexity which increases at a rate of n squared. The output quantity is n to the x, to the inputs n, where x is some constant number. There were 8 of these, quite often calling out n squared. Occasionally, I remember there was one very specific case that I thought was interesting where they said, I think we think of exponential as being more than quadratic or cubic, because we've got names for those, so it must be like bigger than that, which was kind of a neat misconception. There were 4 that just drew steep graphs. Exponential is this steep graph. By the way, this stuff is often funny, but I hope it feels awkwardly funny to you, like, ooh, I think I've said something like that in some subject that I'm non-expert on, because, this is sensible misconceptions that people have, even if they're wrong. So anyway, that's how we landed on this question. This particular one focuses on the function descriptions. We've got another one on algorithm structure. It's not quite as mature as this one, so I chose to do this one instead. And here's some results. So this is for students before Computer Science 121. We have not gotten a chance to run this with students after 221 or 320 yet. Hopefully we'll be doing that in a couple of weeks, and I can give you data on that. So this is what people think of exponential when they've just got that high school mathematics plus Computer Science 121 and Computer Science 110, which they must have finished as well. 73% say a function that looks like this is exponential. That's really popular. 46% the function has the same shape as n squared. Interestingly, if I'm remembering correctly, if you ask them about n to the 4th, they're a little less likely to say that that's exponential. Not much, just a little bit less likely. For large values of n, the function has the same shape as 2 to the n. That was the second most popular exponential one. The function grows more and more quickly as n gets larger, which is actually what I expected people would like a lot, because I saw a few people in the think-alouds describe it this way, but not so many in the exam analysis where I had larger numbers. So basically what this tells us is not that we've got misconceptions late in our program about exponential, although I suspect that we do. I strongly suspect we do, based on the 221 data that we've looked at across several different terms. But it does tell us that students coming in have some strong misconceptions about it. And interestingly, I can actually say something on this one as to whether they were guessing or not. Because in almost every case, there were 0 people or a very tiny number of people that picked the third option in this ABC. It was almost always split between definitely exponential was always popular, right? Between that and either definitely not exponential or not enough information. So if you look at the two where I have verses in green, almost everyone either answered one of those two options or they left it blank. So they don't seem to be guessing. Yep?
I've noticed the word exponential being used in the news when they say things grow a lot quickly. Maybe it's just become the meaning of the word is now a non-technical word that doesn't actually mean what you think it means.
Oh, I entirely agree. I think there's no question that that is dramatically influencing students' misconceptions here. But if we want to keep using the word, then we're going to have to deal with that. And certainly it's interesting that they're coming up with n squared is sort of a boundary, right? Quadratic and up is exponential. Yep.
So I was very curious about the, not knowing and guessing versus having a misconception coming out of high school distinction you made. And I don't really buy your argument about the third choice being an indication of that, because it's very different for me to say, well, I have no idea what this question is asking about, so I'm just going to guess whatever looks best, versus saying,
I know it's
so like a
clearly
blank is clearly an I don't know. Right, but picking, so do you have think-alouds, or do you have a sense, I mean, do students come out of high school thinking like they've been exposed to exponential growth and they have or the news, right, they have the wrong thing, or?
I have much less think-aloud data on this one.
Okay.
So I am unable to answer in more detail on exactly how they're interpreting it. I will say not a lot of people left it blank, and even fewer people chose the third answer. Generally speaking, I think for it grows more and more quickly, there may have been that 5% that's left over, some of them may have picked the third answer. Patrice?
Do you know if there's any studies in, say, psychology which would say something about how likely people are actually to choose not enough information? Maybe there's some reluctance to answering not enough information or none of the above.
Yeah, that is a concern, but you'll notice that a fair number of people do pick not enough information for number 4. We've got 41% of people who are picking the correct answer, not enough information. So, I mean, I am concerned about that, and that happens, both of these questions happen to be ones where not enough information are the answer. I think these are my 2 questions that focus on that. I was worried about that, but they do pick it in large numbers, so. Cool, all right. So we've got a lot of think-aloud validation to do on this. As I mentioned, we don't have as much think-aloud data on that. We're up to that right now. Obviously, we want to do expert validation. We want to compare with those math CI questions. And we're really looking forward to trying this out on upper level students and seeing how much concepts shift over time. So I've got one more story of a concept inventory question, but I don't have a ton of time for it. So maybe I should pause here and just look for questions. Yep.
Let's ask the previous one. What is the claimed correct answer for that?
For which?
Graph 1.
Graph 1. Not enough information.
Yeah, to me, that was the instant answer because there weren't units on the axes.
Yeah.
It had nothing to do with the shape of the curve. It just had not enough information in the graph.
Yeah.
Something that I have hung up on, I was curious. Do you think it's sensible to say a function grows exponentially between 1 and 2 and grows polynomially thereafter? Because if you believe it's possible to talk about a function growing exponentially over only part of its range, that might really blow up some of your...
That is entirely possible. I believe I tried to ask this question.
Yeah, because otherwise you really have to be talking about asymptotics.
Yeah.
The word asymptotic.
The trouble with including the word asymptotic is it limits who I can ask the question
Exactly.
of.
So
Yeah.
I think if you don't include asymptotic, you kind of have to say it's over the given range, whatever that is in the picture, or because otherwise it's just not clear.
Yeah, I mean, I guess what I might do is say as n grows large or something like that, try to give an English description of asymptotics. Alan?
So moving away from, well, I mean, I was going to say moving away from nitpicking on these questions, but actually you want people to
Yeah, please,
So,
nitpick.
But come back to one of Kevin's earlier questions, right? I mean, this, I'm a real fan of this, and I find it really illuminating the misconceptions people have. But this question is sort of generalization, right? This is like we're doing like inductive learning here on the students, where we have a few sample points, and if I learn that, okay, I'll have to explain exponential growth differently than I had been, or gee, I was doing a good job because my students did better on the concept inventory or whatever. Well, there's a whole bunch of concepts like that, and the concept inventory is only covering a small set.
Absolutely.
So, can I generalize this at all, or do we need like an infinite supply of little Steve Wolfmans on sabbaticals to expand this?
Okay, so first of all, what I'd say is there is absolutely no way that we're going to get a concept inventory that students can take in under 30 minutes where we can track over our whole course structure, how they're doing on all of our learning goals. So my target has been a subset of the learning goals that instructors view as important. By the way, just so people know, when I say instructor, I mean instructor of the course. I don't mean people who are in the instructor titled position. View as important and hard. And then added to that are going to be things that come out sort of organically from the studies we're doing, where we see surprising misconceptions that cut across other questions. There's a real danger that we could overfit to these. I don't want us to teach to this concept inventory, but I do want it to give us a little bit of a sense of where students are heading in terms of their learning across the courses. So you're right. What I don't want you to do now is to respond to this by saying, I'm going to spend an extra week talking about the word exponential. How do I expect you to respond to this? This particular question, you might respond to it by thinking about what specific misconceptions are prevalent among your students, right? So you might be surprised to learn n squared in particular is something they view as quadratic, and you might respond to that. More generally, I'm hoping this is an indicator of something about how students are doing with application of terminology that's important in these courses, and it's not going to be a perfect measure. The good news, in a sense, is that if I give you these results and you're a very busy person, which I know you are, then you're probably going to look at them at this level, where you're really just looking at how did they do on this assessment overall and how has that changed over time. And that ought to be a reasonably good, as long as we develop this as a nice sample of important concepts, that ought to be a reasonably good indicator of learning progress. Yep.
The risk to put my foot in my mouth. For the question we asked where the exponential goes as or has the same shape as to the n, what are you actually getting at there? Like, are you asking whether any exponential is asymptotic to the n, or are you asking, like, it's not...
Wait, sorry. So you're asking specifically about the one where I listed 2 to the n?
Yes.
Okay, so number 3. So ask it again then?
So are you asking, I'm curious as to what you were actually thinking when you phrased the question. Are you asking, is every exponential function asymptotic to the n? Or simply when you say shape, that if you were to plot it, there would be some similarities between an exponential function to the n? Or are you asking, is 2 to the n an exponential function? Because it doesn't seem to me obvious from the phrasing of the question which of those concepts you're actually getting at.
Well, I'm asking, does 2 to the n describe a function that grows exponentially?
Okay. Because I didn't read the question quite like that. I read the question as, I have a class of exponential functions. Do they all grow as 2 to the n does?
Okay.
Say asymptotically.
Yeah, I can imagine that interpretation, but I'm surprised by it if it's a general interpretation. I guess
it probably wouldn't be.
Yeah.
But just...
You are typical after all. So. Yeah.
If you get this graph and you say, when n is 0, what's the value of f of n? And someone says 0, which to me it seemed like it's 0. So I said the answer is no, it can't be an exponential because it's 0, it's going to be 0.
Yes, I've actually had one person mention that in a think-aloud interview, which was terrifying to me. But then I looked back at the assessment where we gave this question, and nobody said definitely not an exponential. So I don't think that that's actually a general conclusion. It's also the case that since we can't see the scales, I mean, if we want to get really nitpicky, it's impossible to tell if we actually get to 0. We just may get really close to 0, and who knows. So I am considering moving this up a little bit so it's obviously off the axis, but since people are by and large saying it is exponential, I don't feel really strongly that there's a need for that. Cool. Well, I guess, I could spend a few minutes talking about this, but let me just see if there's any one thing that I really want to show you all from all this. And I think the answer is probably no. Well, I'll tell you what we're in the process of right now. So we're working on recursion, recurrences, and dynamic programming. We've done a bunch of exam analysis on dynamic programming, and this is mostly our conclusion. If you look at dynamic programming problems, even ones that are broken up into pieces, this is the prototypical answer. I have no idea. Where they have an idea, it's often an idea that looks remarkably similar to the answer to another dynamic programming question, which is not the one that they've been asked. So this turns out to be really hard for students. We are getting better data as we work on better ways to scaffold the dynamic programming question. So it's possible that one thing that'll come out of this is that we learn a little bit about how to scaffold our students as they work through dynamic programming problems. But this is kind of the current investigation that we're busy on in some of your courses right now, but only if you know about it, so 2 of yours. And that's kind of it.
Are you giving these questions as just bonus questions, or are these actually in real tests?
Where I've mentioned that we gave something on an exam, it was an exam question. We do not want the concept inventory questions asked on exams, however, because they should be low-stakes questions, and we don't want there to be any motivation for people to go out and study the concept inventory. There's been a fair amount of research about what people retain when they take the concept inventory, and then they take it again k weeks later. And for k not extremely small, the answer is close to nothing. Which shocks me because I'm 100% confident that I would retain something. But then I remember how much I really liked taking tests as a student, and I wonder how many of my fellow students felt that way. And I start doubting that I am typical. We don't want these on exams because we don't want any motivation to study for them, and we do want to be able to reuse them a lot. Makes sense. But that doesn't mean they can't be based on exam questions.
Yep. Getting back to a question where the poor gentleman or lady had no idea. Have you posed the same question without the big black, this is the hardest question on the exam? Because my word.
There is the this is the hardest question on the exam.
So
yes.
If I don't immediately know the answer, it must be impossible. Ergo, I should not even attempt to solve it. Ergo, I have no idea. Seems like a perfectly valid answer to this question.
All right. So let me moderate my answer. I said yes, but actually maybe the correct answer is no. Because in fact, for students who know how to game exams, all of the dynamic programming questions we have studied have the big black bold message implicit in them because they are all either the last or the second to last question on the exam, and they're worth a lot of marks. So maybe that is the big black bold message that says, this is a really hard question, don't bother answering it unless you're really confident. Nonetheless, we're not getting interesting data from the exam analysis. It's just a hard.
You want me to put it first on the December exam?
Yeah, put it first. Maybe second. Yep. Bill.
How much are you trying to, I know the physics concept inventory is very visual.
Mm-hmm.
Like you really, there's no diffy cues, there's nothing. And in particular, like your first thing on the trees that was super visual, I could imagine like dynamic programming questions that were very visual. So I'm just wondering so that you kind of need less like it would be impossible to give somebody who had never taken any computer science a question about dynamic programming. And yet, I wonder if there's a way to phrase it where you don't use those words, but you, as you said, sort of scaffold it, visual. Like, are you trying to do that? Are you trying to get it? I'm just kind of curious, because I got the sense that the physics people tried to do that.
Yeah, I mean, one thing I'll say is I've strived for that and found it difficult. So, you know, I'd love to come up with something where every single question could be offered to a student before they've taken 121, before they've taken 110. I don't feel like I'm there. The flip side of that, by the way, is you definitely can ask dynamic programming questions of people who have taken no computing. It's actually not that hard to take a dynamic programming question and rephrase it enough that it's still the same question, but students can give it a whack. And that's one of the reasons why, by the way, why I'm kind of fixated on getting dynamic programming to work, because I think it's a nice question that gets at things instructors have told me they really care about: recursive thinking, inductive thinking. And yet we can ask it over the whole curriculum and watch students' trajectory as they proceed. But, yeah.
Okay, maybe it's 10 to 5 now, so we can wrap up, but of course Steve's here, so you can always talk to him and suggest new wording for his questions. Thanks.
Raymond, you're
Oh yeah.